In this video, we're going to work through functions. We're going to look at functions in three different forms: the formula, the table, and the graph. And we're also going to learn how to evaluate functions. So let's go ahead and get started on our worksheet. We've got the topics up above there, but I want to go ahead and start with the definition of a function. So a function is a rule, and it's a rule that matches elements or values from a first set, and we call that first set the domain, with exactly one, and this is what makes it a function as opposed to just any other rule, with exactly one value from a second set. And we call that second set the range. Now with mathematics, we're typically working with x's and y's as we're graphing, so that domain is referred to as the x values, and the range is most often referred to as those y values. So we're matching x's with y's. We see this notation here in number 2, f of x is equal to x squared. F of x is the name of our rule, but we can also call that a y value. Let's work through this example here. So in this example, we've got our rule. We're going to take the x. So this is going to be the x here. This is our domain. And we're going to match it by squaring it with the range. So we're going to express that function in three different forms, which I've done below. So we've got the formula, the graph, and the table. And we want to use these representations to evaluate f of 2. As we work through the formula tells us what to do. So that 2 is an x. We're going to match an x with a y value. This is our rule. So f of x or y equals x squared. So we're going to match 2 using our rule with 2 squared. And that's going to be 4. So f of 2 is 4. We can also see this graphically. So on our graph, the horizontal axis represents the x's, and the vertical axis represents the y's. So we've got 2 here for an x. Remember, I want to match 2 with a y value. So if I go ahead and look up to the point on my graph, it's this point right here, which happens to be 2, 4. So that means that 2 matches with the y value of 4. We can also read that in function notation as f of 2 equals 4. Okay, finally, our table. So in our table, I look through the x values and I find 2. This is the easiest one to read. And I see that 2 has been matched with a 4. All three representations, of course, give us the same value for f of 2. In the second row here that we want to work through, we're given the y value. So we know that y is equal to 1. We want to work backwards and find the x value. Let me change pen color here so it's a little easier to follow. So I know that y is equal to 1. So I'm going to go to my y-axis and find 1, which is right here. 1 lines up with 2 different points on my graph. I've got a point there and a point there. The points on my graph tell me what the match is. So if I look at this first point, it matches y equals 1 with x as negative 1. And we express that in alphabetical order. X comma y, negative 1 comma 1. If we look at the second point, it matches with an x of 1. So the second point, x of 1 is matched with a y of 1. So going down here, if f of x or y is equal to 1, that matches up with both a negative 1 and a 1 for the x. So I've got 2 different values that match up to a 1. We can do the same thing here with our table. We're looking for y's, which are that x squared value, that are 1s. I've got 2 of them here. The x's that they match with are the negative 1 and a 1. Again, different representations, but we're still getting the same values. Here's our next example. So in the next example, we don't have the 3 representations. So as I work through this example, we're going to make really good use of the Desmos site. If you haven't used the Desmos site before, don't worry, it's really easy to use and completely free. So let's go ahead and move over to the Desmos site. So I'm just typing in desmos.com, or you can do a quick Google search for Desmos. You do not need an account. I'm just going to go ahead and click on Graphing Calculator. And your screen's going to look just like mine. I've got the graph over here on the right and some empty cells over here on the left. Whatever I'm evaluating or working with, I'm going to type here in the left. So from our worksheet, we want to type in f of x is equal to x minus 3, and that x is an absolute value. I'm going to show you 2 ways to do that. So f of x is equal to, now I need my absolute value bars. I'm going to go to my keypad, and some of the functions are listed here. The numbers are also listed here. And I've got my absolute value symbol here above the ABC. If you don't see a function you're looking for, you can go to the Functions tab over here. But I'm going to go ahead and click on the absolute value. And then I want to type in what I had, and it was x minus 3, right? So it gives me that first representation. I can go ahead and minimize my keyboard there. Okay, so I've got that first representation. Let's go ahead and just move that over. We also have our formula, right? So f of x, that was given to us, absolute value of x minus 3. I can go ahead and just do a quick sketch. Oops, this is x, not 3. There we go, x and y. And if I take a look at my Desmos graph, I see it goes down to 1, 2, 3. So my v goes down to 3, and it crosses, or sorry, negative 3, and it crosses at 3 and negative 3. I'm just going to sketch it. So it looks like this. Okay, so there's my graph representation. I also want my table representation. So this is going to have an x and a y. This y, you can call this y f of x. You can also call this y by its rule, absolute value x minus 3. Desmos does the table for me as well, which is great. So if I click on this gear, edit list, I can change my list into a table. So I'm going to go ahead and click on this convert to table, and it gives me a table of values. I can change the table of values if I want. There are infinitely many points here, so I can change that to a 4. I can change that value to a 5, right? There are infinitely many of these. Whatever you've got works just great. So I'm going to leave that as a negative 2. So we can go ahead and copy this one over as well. So we've got our table 2. Let me see if I can just minimize this guy and get both of them so we can see them both. Okay, so let's go ahead and put this into our table. And we'll make that a little bit smaller. And then I'll show you how to do the evaluating in Desmos, which is just so nice and easy. Okay, so on our table here, we want to go ahead and just put in a few of our values. So negative 2 matches to a negative 1. Negative 1 matches with negative 2. 0 matches with negative 3, and so on. 1 with negative 2. 2 with negative 1. I could, let me make this large again, I could check each of these. So I was using my, my Desmos program to evaluate these, but I could also do each of these individually, which I don't necessarily want to do, but I could. So for example, if I wanted to figure out what f of negative 2 was, so f of negative 2, remember negative 2 is my x value. X goes right here, so it's the absolute value of negative 2 minus 3. Absolute value of negative 2 is 2 minus 3, and I get a negative 1. So that tells me that negative 2 is matched to a negative 1. So negative 2 is matched to a negative 1. Desmos just makes really nice, quick work of this. Okay, so we also want to be able to find these values. So moving here into the second row, we want to find f of negative 3. I'm going to show this to you both ways. I can use my formula. So negative 3 is my x. So I put my x right inside those absolute value bars, minus 3. absolute value of -3 is 3, minus 3 is 0. So I end up with 0. I can also go over to Desmos, which is right here, and I can put that value in. I can go ahead and put it into my table. I have -2, but not -3. Let's go ahead and put that in, and it confirms that it's matching it with a y value of 0. So just a nice way to go there. Okay, so back to ours. Next, we want to do f of -3 using our graph. So -3 is my x, so x is equal to -3. You may or may not remember, but this value right here was -3. It's on the x-axis, so that point is actually -3 for x and 0 for y. So we get a 0 there. If we go back to Desmos, let me make this large so you can see the graph. 1, 2, here's -3. I can click on that point and it gives me -3 for x and 0 for y. Remember, y is the same as f of x. So we can find that from our graph as well. And then finally from the table. So f of -3, I don't have it up here on the table, but I can go ahead and put it in the table just as we had done in Desmos there, and I again get 0. Okay, so we've got those. Let's also work this backwards. So to work it backwards, I'm actually going to start here on the table. Let's start over here. So if I'm working it backwards, let me change color. Now f of x is equal to -3. F of x or y is -3. I want to go backwards. So I find where y is -3, and I find what x that got matched to. It got matched to an x of 0. So 0 goes here. We know we're going to get the same values, but let's go ahead and work it through. If f of x is -3, this tells me that y is -3. 1, 2, here's y at -3. That is matching with 0 on the x-axis. We can do that with the graph too. Let me show you that with the graph. Desmos. So with the graph, I go ahead and find where y is -3. I click on that point and it gives me an x of 0. So Desmos just makes really, really nice work of these functions. Okay, so next, I'm going to give you some graphs and we want to decide which one represents y as a function of x. This is really going back to that definition. So a function matches each x or value from the initial set with exactly one y value. So that's another way of just sort of shortcutting this. So if I give you a function like this, and I already told you it was a function. So yes, it is a function. I can go through and determine if every single x value, let me grab a different color pen, is matching with a single y value. And I can do that just by sort of lining them up. Yes, -4 is only has one match or 1 point, -2, and so on, right? Each of these only matches with a single point. So I could say, yes, this one is a function. So yes. Let's look at one that isn't a function. Let me go back to my purple pen here. So if I go to one that isn't a function, let's do like this one right here. So this one, for example, I can take a couple of points and I can see that one, let me grab my yellow, is matched with 2 different points. So I grab an x, yellow. So I grab an x and I see that x is matched here and it's matched here. So that tells me that 1 is matched with 3, but 1 is also matched with -3. So each x has to be matched with exactly 1, and we have not done that, so I can say no. But you can see how these two live on the same vertical line. So I can use the vertical line test to check to see if this is a function or not. So if I run through, I'm going to go ahead and grab a red pen, and I draw some vertical lines through this first one, my vertical line will only ever cross one time. If I do the same thing to my second function, the second graph, the circle, I start crossing more than once. And that's telling me that these x values are being matched with more than 1. Okay, so this one was no. This one was yes. Let's do one more. So on this last one, let me go back to my purple pen. I guess my red pen. On this one, I want to see if I'm matching with more than one value. I'm going to check it with a vertical line test. And I can see as I work through here, it's only being matched once. I know this kind of looks vertical. It's not supposed to be. So this one is also yes. Okay, I'm going to give you a challenge. I want you to draw. Just going to give you a little grid here. I want you to draw a graph that is a function and one that is not a function. So see if you can graph one that is a function and one that is not a function. I'm going to start with not. Whatever you drew, it doesn't have to look like this. Whatever you drew needs to fail that vertical line test. I need to be able to draw a vertical line through at least one place and match up with a couple of different points. So there's one that fails the vertical line test. Okay, let's go ahead and keep on working through our worksheet. Same question here. So which of the following represents y as a function of x? So we're going to use the same rule with exactly one. So I'm going to look at my x's and make sure that they're matched exactly once. So as I look at my x's, a really good way to do that is just to look for duplicates. And I've got two negative ones there. So negative 1 is matched with a 3 and negative 1 is matched with a 5. So this one is no, not a function. For the next one, these are all matched to the same value, 4, but that doesn't matter. What matters is that the x's are only matched once. There are no repeats in the x's, which means that each x is matched to a single y. So this one is yes. Next one. Again, I'm looking for a duplicate x. Is there 2 matches for one x? And the problem child is that 5. So 5 is matched to a 1 and it's matched to a 4. So this one is no. Okay, again, we have 2 x's. And then finally, in the last one, I look through these 1, 2, 3, 4. So there are no matches or no double matches for a single x. So this one is yes. So we've got 2 functions and 2 that are not functions. Okay, so here we're going to be evaluating some functions, and we're going to go through, and I'm going to do some of these by hand, and I'm going to do some of these with Desmos. Desmos is really, really nice to work through. I'm just going to do the first one here by hand, the first ones, I guess. So for this first one, g of negative 2. Negative 2 is my x, so I'm going to put a negative 2 there and a negative 2 there. It's hard to see. So that's going to be 3 negative 2 squared minus 4 times negative 2. I'm going to do that power first. So that's 3 times 4. And then I can multiply the negative 4 and the negative 2. That's going to be plus 8. 12 plus 8 is 20. Let's do this with Desmos. So I'm just going to make this smaller. I've got Desmos here. Let's make this guy smaller. And I'm going to put in a new function. And that new function is going to be my function g. Let's move this guy over here. So I'm just going to X out what we had so we can just kind of start fresh here. So I'm just going to type in this function, g of x is equal to 3x. I use the caret key above the 6 squared, arrow over so that it's down on the right line, 4x. Whoops. Minus 4x. Okay, so there we go. I can do a couple of things. I can go ahead and type in values of x here. I can say x equals, let's do negative 2. Let's see, that's not what I want, is it? So actually the easiest way to do it is this way. So I'm going to go g of negative 2, since I already defined the rule. There we go. So g of negative 2 is 20. And then I can just continue to change this. So I get 20, I can type 5 in. How easy is this, right? I get 55. So I've got that second one so easy, 55. And then this last one is g of 1. which is -1, but I'm subtracting g of 3, -16. So that's going to be -16. The other way that you could do this is with a table. I think it's really nice just evaluating it this way in Desmos, but you could, if you wanted to, put your cursor here and then hit the edit key, that gear, and then change it to a table. And you can put in your -2. You can put in a 5 to get the 55. You can't put these in twice, but you could put the 1 in, and you can put the 3 in and then subtract those to get the -16. Personally, I like doing it this way. Either way is fine though. Let's do h of x. Let's use Desmos. Okay, so h of x is equal to negative, and then we've got the absolute value, which we can grab here by opening up the keypad. You can also type in ABS. This is pretty easy though, just to type that in. So I have the negative and then the x minus 4 on the inside there. And I can go ahead and just evaluate these. H of 1, H of 4, right? How nice. H of 1. I could do this in my head, I guess, but it's fun to do it this way. H of 4. So we get -3, 0, and -3. So -3, 0, and -3, right? It's really nice. Okay, so let's work back over here. There we go. Okay, so for the last one, I'm going to X these out just because I'm making a mess here. And then I'm going to type in this fraction, and I'm just going to show you how to type a fraction into Desmos. Really pretty easy. Let me get rid of all this stuff first. There we go. This fraction we're calling f of x. So our rule is f of x equals, we have x plus 2, but to get our fraction, I'm going to go x plus 2 divided by, but it puts it under the 2. So I'm just going to edit it a little bit and do the x plus up here. Let's get rid of the x plus out here, just making sure it looks correct. And then x caret 2 for the squared. Right arrow to get where you want to be, minus 4. Okay, so we've got it. And then we can go ahead and start evaluating. F of -2, undefined. Do you see why that's undefined? First of all, if you look at the graph, this is really hard to see, but on the graph, -2 is right here, and there's no point. But if you put -2 into this, you're going to get a negative in your, or sorry, a 0 in your denominator. So if I do this over here, f of -2 is -2 plus 2 over -2 squared minus 4, which is 0 over 0. That's undefined. Okay, so undefined. So we can just confirm what Desmos has given us. And I can do f of 3 and get that value, and then 4 times, and I just used the asterisk above the 8 to get the time symbol, f of 0. So I can just do all of that together then. So I get a 1 here, and then a -2 there. So Desmos is a really nice way to work through these values. You can also do some things using your graphing calculator. I'll be working with the graphing calculator too as we go through, but Desmos is a really great one to work on this worksheet and this section in. Finally, we've got the common functions. You need to be familiar with these common functions. You need just to be able to recognize that a horizontal line is a constant. You need to recognize that a V shape is the absolute value. So make sure that you've printed this off. You've got it for quick reference. We're going to be doing lots of different things with these domains and ranges. We're also going to be doing some transformations with these. I know up above one of the questions said domain and range, and I skipped that because we're going to be doing domains and ranges in another video.